Okay, we're going to do a whole bunch of stuff on the point 2, 4. So I'm going to draw a little graph in the top right-hand corner and put the point 2, 4 on the graph and call that a point on f of x, or x comma f of x if you like. Now, what if I want to take the function g of x and say g of x is equal to f of x minus 2 plus 3. Well, I know that if I had f of x and I put x minus 2 in for x, I know that that is, I'm going to write my old point down, 2 comma 4, and I'm going to underline it. I'm going to say what I'm going to do to it off to the right, left, horizontal translation equaling positive 2. Excuse me. Substituting x minus 2 in for x does the opposite operation and does a horizontal translation, positive 2, getting the new point, adding 2 to the x value, 4 comma 4. Then this plus 3 off to the right, I remember that if I see a plus 3 off to the right, that is a vertical translation. And if it's off to the right, then I do as it is, and I simply add 3 to the y value. And I get my final point. Again, remembering doing it extremely tabular, so it's all clear, and circling your final answer, and feel free to move that graph to the right 2 and up 3 and make sure that it's at 4, 7. So let's take a look at another example. So let's say g of x is now equal to negative 2 f of x plus 1 minus 1. Well, people are always going to ask questions about order, and we're going to talk about order matters throughout. But if you just remember bedmass, and we do addition and subtraction after multiplication, bedmass, multiplication before addition and subtraction. If you just do addition and subtraction last, you'll be fine. So this 2, this negative out in front, is a vertical reflection. Excuse me, I'm going to do it in tabular form. So I am going to write the point down that we were given, 2 comma 4, and I'm going to say what I'm going to do to it off to the left. I want to do a vertical reflection. So this negative in front is a vertical reflection, and I'm going to actually start to write what I'm going to do to the point. As you've seen in the notes in the above example, we took x and we added 2 to it. We took y and we added 3 to it. Here I'm going to, if I want to do a vertical reflection from this negative out in front, I'm going to simply take the y value and multiply it by negative 1. So if I have a y value of 4 and I multiply it by negative 1, I get 2, negative 4. Now we're going to work on this 2 out in front, and I know that if I have a 2 out in front of f of x, that is a vertical expansion equaling 2, which is multiplying the y value by 2, which would give me 2. Negative 4 times 2 is negative 8. Now I can work on my translations. I just need to do them last. And this positive 1 inside the brackets with x is going to be a horizontal translation. Left 1, negative 1 to the left 1. And if I take my x value and I subtract 1 from it, I get 1 and the y stays. 2 minus 1 is 1. Now I'm going to work on this negative 1 off to the right, and that negative 1 is a vertical translation equaling negative 1, and the y value is going to be subtracted 1. If I have negative 8, it moves down to negative 9. That is my final point, negative 1, negative 9. Feel free to transform that point on the graph in exactly the steps we did. Graph it out on your own graph paper. Do all those steps. So let's take a look at a bunch more examples. So again, let's take the point 2, 4, a nice easy point to work with, and let's call it f of x, or x comma f of x if you like. Now we're still on the last page of notes, we're just about halfway down, so let's find g of x is equal to f of negative 1/2 x. Well, I know that this negative is a horizontal reflection, so I'm going to write the point down as always, the point that I was given. I'm going to underline it. I'm going to say what I'm going to do it off to the left. So again, this negative in front is a horizontal reflection, and I'm going to write off to the right what I'm going to do to it, and that's x times negative 1. And if I have an x value of 2 and I multiply it by negative 1, I get negative 2, and the y value stays. Now I'm going to work on this 1/2 in front of x. Well, I know that someone must have substituted the opposite operation for the variable. So if I see a 1/2 x, I know that that's going to be a horizontal expansion equaling 2. And I'm going to take the x values, and I'm going to multiply them by 2. So if I have an x value of negative 2 and I multiply it by 2, I get negative 4, and the y value stays, and that's my new point. So this one is more interesting. We're not only taking the point 2, 4, we're introducing a new point. So let's go for a new function. G of x is equal to f of 2 open bracket x minus 2. Notice these brackets are factored. They have to be. You have to be in factored form or the letters do not work. So let's talk about this 2 in front, and that I know if I see a 2 in front of the x, it's a opposite, so that's a horizontal compression of 1/2. So I'm going to do the point 2, 4 this time, but I'm also going to do another point 4, 6. So I'm going to underline both of the points, and now we're going to focus on this 2 again, and remember that is the opposite, so we do a horizontal compression equaling 1/2, simply taking the x values and multiplying them by 1/2, and an x value of 2 times 1/2 is 1, y stays, and an x value of 4 times 1/2 is 2, and y stays. And then I'll work on this negative 2 attached to the x. So that's the opposite. So that would be a horizontal translation. If it says negative 2, that's equaling positive 2 to the right 2. And I'm simply going to take the x values and add 2 to them. So if I have an x value of 1, I would add 2 to it, and I would get 3, and the y value stays. And if I have an x value of 2 and I add 2 to it, I get 4, and again, the y value stays. And now I have my 2 new points on the graph, 3, 4. Again, notice the tabular. Very simple. We do one thing at a time, especially if you're in a test and you want to review your stuff. It's easy to look back at the equation and decide on what the things do, confirm that you've said that they do the right things, confirm that you're going to do the right things to the variables, and then do them one line at a time. So feel free to further read the notes. We have an example where you're forced to factor the brackets or factor out a negative 1 or do algebra necessary to get to different attributes of the equation with parts that you like in those parts. The last one we're going to do on this page is the inverse. So if I say g of x is equal to f of negative x plus 2, well, that means it's going to be the inverse calculation. And if I want to do the inverse calculation, I simply say this little tiny negative 1, and that's the inverse. So I'm going to write down the old point that we always start with, 2, 4, and I'm going to do the inverse. So that's f negative 1, and that means simply switch x and y. Switch x and y. A very simple method, the inverse. Now if I'm looking at this positive 2, then I simply do a horizontal translation equaling -2, which would subtract 2 from my x value, and I get 2, 2, my final point. Remember, function operation stuff first. An inverse calculation like switching x and y we do first, and then we do everything else after that, remembering we do translations last. Okay, so let's take, let's take f of x is equal to x squared. And let's say we want to do 3f of -x plus 2. I don't know what that equals. Call it g of x, call it whatever you want. But I'm going to start by saying f of x equals x squared. And I'm going to simply say the exact thing on the left-hand side as the question asks for. And on the right-hand side, I'm going to do what I said I'm going to do. So what I did on the left, I'm going to do on the right. So I put a 3 in front of f of x. So I'm going to put a 3 in front of whatever my function is. Then I'm also going to put -x in for x. And I'm going to leave the squared because it was already there. And then I'm just going to put a plus 2 off to the right. Just working with function notation. Substituting in for f of x. Putting numbers in front, putting numbers off to the right. Speaking about what they do, this 3 in front is a vertical expansion equaling 3. This negative inside is a horizontal reflection. This positive 2 off to the right is a vertical translation equaling positive 2. Remembering that you may be given the instructions to do and you have to do that, or they give you an equation and you have to do that to the variable x squared and leave it in this form. From given this based on this original information. They gave us f of x equals x squared. They said, what's that? Again, remember, they could have said g of x equals that, and we could have called our answer g of x. Don't get too worried about the notation. So let's take a look at another example. So what if I took the same equation, f of x equals x squared, and I said, what's 2 f of x minus 1 plus 5 equal to? And why don't we call it g of x this time? Who cares? Call it h of x. Call it whatever your teacher called it. So what's g of x? Well, I'm going to mirror the equation. G of x would equal, so f of x was x squared, and I want to put a 2 in front of whatever it was, and I want to put an x minus 1 in for x, and it's still squared because it was before, and then I want to put a plus 5 off to the right. And they may ask us what each of those individual things do, like a vertical expansion equaling 2, or a horizontal translation equaling positive 1, the opposite inside, or a vertical translation equaling positive 5, up 5. Again, they may tell you to do these things in an English sentence to the equation given, y equals x squared. Then you may have to do it, and you might call it g of x or whatever function they told you to call it, just substituting in for x or putting numbers in front. And remember, we can work in function notation or variable notation, and we're going to do a bunch more of all of them. Okay, let's go back to variable notation. Y equals x squared plus x. Interesting. And we're going to do the English instructions from the notes. Make sure you're printing off all the notes and flipping pages accordingly. So it says all those English instructions. I'm just going to be doing it. So we're going to first be doing a horizontal reflection. That means that I'm going to take x and I'm going to substitute negative x in for x. So I take the equation and I simply substitute negative x in for x. Everywhere I see an x, I put a negative x in. Then I can clean it up if I like. So negative x squared is x squared. And if I have a positive in front of a negative and I distribute it, it becomes this. Totally different function than before, a vertical reflection. Now let's do a vertical expansion. So what if we want to do a vertical expansion equaling 2? Well, that means that I'm going to want to take y, and I'm going to want to substitute the opposite operation for the variable. So I'm going to simply put 1/2 y in for y. Now when I clean this up and I multiply both sides by 2, remember sometimes I'm going to show you, but most of the times I'm just going to talk about it. And I'm going to multiply both sides by 2, and I'm going to get y equals 2x squared minus 2x. So before, that was my equation. Now this is my equation. If I put 1/2 y in for y and then I multiply both sides by 2, that affects both things on the right. So anyone who would just lazily have put only that 2 there would have gotten it incorrect. So sometimes I need to shrink my work a tad, but I hope you're copying down or following the notes. So now let's do a vertical translation equaling positive 1. So remember, we're doing these in sequence. So we were there, now we're here, now we're going to keep going. So if I want to do a vertical translation up 1, I simply take 1 and I substitute y minus 1 in for y. So if I do that, I get y minus 1 equals 2x squared minus 2x. And then I can simply add 1 to both sides of the equation. And I get my new equation. Then I want to do a horizontal translation equaling negative 5. And I want to substitute the opposite operation for the variable. So I'm going to turn into x plus 5. So everywhere that I see an x, I'm going to replace it with x plus 5. And that is my final equation. Following the steps properly, I don't need to do any sort of expansion. I could, but usually the teachers are going to be okay with just leaving in this form, doing the proper steps. Again, if you start to do lazy stuff like putting 2's in front or just putting plus 1's off to the right, you may accidentally make errors along the way and get frustrated. So until you're more familiar and feel better about the material, let's do things properly, substituting the opposite operation for the variable. Okay, let's take our good old graph of y equals x squared. 0 squared is 0, 1 squared is 1, 2 squared is 4. And let's call that function y equals x squared and work on it over here, y equals x squared, and let's say what we're going to do to it. So we're going to do a vertical expansion equaling 2, taking the y and substituting 1/2 y. Substituting the opposite operation for the variable. So 1/2 y equals x squared, and then feel free to multiply both sides by 2 if you like. So we're halfway there. So now let's do a vertical translation equaling positive 1. So I'm going to take y and I'm going to substitute y minus 1 in for y. So if I do that, I get y minus 1 equals 2x squared, and then I can add 1 to both sides, 2x squared plus 1. So the first is going to be the vertical expansion. So if I have a y value of 0, that stays. It's invariant. If I have a y value of 1, I multiply that y value by 2, and I get 2. And that is my vertical expansion of 2, y equals 2x squared. Now what if I want to take that graph and I go up 1? Well, I'm going to take each and every point and go up 1, and I get my new graph with the same shape as before, just up 1. y equals 2x squared plus 1, doing multiple steps. Usually they're going to give it to you in the proper order where we do the multiplications and the divisions before the additions and subtractions. But a little bit later we're going to get to what happens if we don't. Okay, notice this one I had to use a little bit smaller graph paper for the time being. So let's draw the original function, the red, and call it y equals f of x. And let's draw the black. And ask ourselves what's happened. So we're going to start off with the function as given, f of x, and we're going to transform it into the function y equals a, f of x minus, b, f of b, open bracket, x minus h, close bracket, plus k. So I'm going to start by writing my function y equals f of x. And I'm going to ask myself the following question, seen in the notes. How wide is the red? Well, it's 2. How wide is the black? Well, it's 4. What's happened? It's a horizontal expansion equaling 2, which means that I'm going to take x and substitute 1/2 x. So I now have the function y equals f of 1/2 x. Then I want to ask myself how tall the red is. Well, it's 2 tall. Now how tall is the black? Well, it's 6 tall. So that is a vertical expansion equaling 3. And I'm going to take y and I'm going to put 1/3 y in for y. So 1/3 y equals f of 1/2 x. So I'm going to clean that up and multiply both sides by 3. So now I ask myself any reflections, and yes, I can see that I know that I have a vertical reflection. And in the notes, you can see that I've taken a y and I've put negative y in for y. But then divide both sides by -1, and y just equals negative of what we had. So in the notes, you can see multiple steps, but sometimes we're going to be skipping a few of those steps. So after we've done all the multiplications and the divisions, before we work on the additions and subtractions, we want to pick a point on the graph, like 1, 2. And we want to write that point down, 1, 2. I want to underline it. Then we're going to say what we did to it. So we did a horizontal expansion equaling 2. Multiplying the x value by 2. Then we did a vertical expansion equaling 3, multiplying the y value by 3. 2 times 3 is 6. Then we did a vertical reflection, multiplying the x value, the y value by -1. So where's that point? Let's put that point on the graph in big red. 2, -1, 2, 3, 4, 5, 6. And let's label that point 2, -6. Well, now we just want to ask ourselves, has the point moved? So our new point in big black on that black graph transferred from the point 2, -6. That means we're going to the left 4 and up 2. So if I want to go to the left 4, that means that that's a horizontal translation equaling -4. And I'm going to take x and I'm going to make it x plus 4. Then I'm going to substitute that in. So y equals -3f. And remember, I'm going to substitute with brackets x plus 4. And then I want to go up 2, so that's a vertical translation equaling +2. And I'm going to say y and I'm going to make it y negative 2, so I'll say y minus 2 equals negative 3 f of 1/2 x plus 4. And as you can see in the notes, I've added the 2 to both sides, but just to frustrate some of you, I'm just going to leave the negative 2 on that side because that's where I'd prefer it. And that's the new equation of this new graph of f of x. In black on the graph, it's been horizontally expanded, vertically expanded, reflected, and then translated. And we have to do it in that order. After we've done all of the multiplications, then we have to pick a point. We have to pick a point, do what we said we were going to do to it, then ask ourselves, has that point moved, and then move that point and get a nice final equation in perfect form.